Okay, everyone, we'll get started with Unit 9 notes on volcanoes. Vocabulary to start, we have the magma chamber, vent, and crater. These are all parts or anatomy of a volcano. The magma chamber is the molten rock that sits underneath the volcano in a sort of pocket. Vent and crater are really similar to one another. That's obviously near the top of the volcano where pyroclastic material is able to exit. Next, we have caldera, lava plateau, and rift zone. Calderas are particularly interesting. That's where the magma chamber actually empties of any of the magma inside. So that void left over actually collapses in on itself, and as a result, there's enormous depressions that are left that are sometimes needed to be looked at from like an aerial perspective because they're so large. You're pretty familiar with plateaus already. A rift zone, though, it's important to note, that's where an area in which tectonic plates are pulling away from each other. And if you remember earlier when we learned about earthquakes, we had three different boundary types. We had convergent, divergent, and transform. A rift zone that's pulling away from one another, that's a great example of a divergent boundary. Next we have hotspot, and then the Latin prefix ig. So hotspots are pockets or plumes of magma that rise up from the mantle, and then they rise up into the lithosphere. And though this is far away from any tectonic plate boundaries, which is kind of a unique sort of geologic activity. The islands of Hawaii serve as a great example of this. The Latin prefix for fire is ig. Think of an igneous rock like a basalt or a granite. Those are formed when magma or lava cools. And again, that's where that prefix comes from. Two other Latin terms that we have as well, we have vol and calor. Vol is Latin for fly. Think of material exiting a volcano and flying through the air. And then calor, that's where the root word of calorie comes from. So when we actually measure calories in a given food, we're trying to figure out how much heat, or rather how much energy, is contained within. So that way we have a measurement of what that's going to do for our bodies in terms of energy. So how is it that these volcanoes can become so incredibly explosive? We have to remember that not only is there molten magma trapped underneath the volcano, but there's gases within it. And as we heat those gases, they continually want to expand. But because they have nowhere to go, that pressure continues to build and build until finally the volcano gives way, and that's what we have that results in such explosive eruptions. So it's that heat energy causing the gases to expand. Again, that pressure increases to an unbelievable level. An analogy for you is just like when we shake up a can of pop and then finally open up the top. All that carbon dioxide that's dissolved within, it's given a chance to escape through a central vent. That's the top of the pop can, in the same way that a vent or crater up top at the top of a volcano. Here we have some anatomy of the volcano. We have the magma chamber, conduit, and vent crater. The magma chamber, as we mentioned earlier, a body of molten rock that feeds a volcano, and that's often found deep underneath the ground beneath the volcano. The conduit, just like how we use conduit to carry electricity or electrons to wiring and lights and things like that, conduit is a way for magma to travel vertically from the magma chamber up to the vent or crater. And again, near the top, that's the opening in the surface where material can escape, gases can escape, and so it can actually vent, literally, that sort of material and that pressure to the external atmosphere. So some great photographs of some calderas, and you can see their enormous size. Again, what events do cause calderas to form? That's when a magma chamber far below the volcano actually empties out of any of its volcanic magma, and as a result, that void left over, that empty space, collapses in on itself and causes the ground above it to sink into a depression. We have some really interesting lava types, and these come from some Hawaiian words. I'll do my best on pronunciation too, but we'll break down each of which is kind of unique in the way it flows and the way it forms. So first off, we have a'a, that forms a brittle crust due to lava flowing very quickly. Think of like the crust on the top of a brownie after you pull it out of the oven. And then we have pahoehoe, and that's very slow flowing. It almost drips like wax from a candle. It can form these glassy wrinkles, so a pretty interesting lava rock type as well. Excuse me. Some other lava types, we have pillow. That's a type of lava that forms actually when lava enters into an underwater environment and it pillows up and makes these round fluffy balls. And then finally, we have blocky as well. That's due to a more rigid lava type that has a higher viscosity, and as a result, it doesn't travel very far from that top of the volcano vent. So it forms those rocky, blocky layers that we see. Some different types of pyroclastic material. This is material that can exit a volcano upon an explosive event. So ash, you may not realize those are very, very small slivers of pyroclastic material. So some of the rocks that are broken down, think almost like slivers of things like silica, quartz. Those are what that fine ash is made of. And that's why it's so dangerous for people to breathe in because of volcanic events. Volcanic bombs are actually when magma is hurled up into the air and then it exists as lava. It cools as it's drifting through the air and can form these huge rocks as a result. And lapilli is just a smaller version of volcanic bombs. That comes from an Italian word. Think of smaller droplets of magma that are flying through the air, cooling over that time and falling to the earth as pebbles. We have three types of volcanoes, and those are featured over on the right-hand side. These serve as good examples of each. First, we have shield volcano. Next, we have cinder cone volcanoes. And then finally, we have our composite volcanoes. So we're going to break down each in detail, talk about some of the similarities and differences between them. So for shield volcanoes, enormous in size, they're formed by very runny lava that's very runny in nature. So that way when that lava is exiting out of the earth, it's traveling a long distance. And as a result, they don't have steep slopes, but rather gently sloping sides. They can be absolutely enormous. Hawaii has a lot of shield volcanoes, and Mauna Kea is featured here in the picture. Mauna Kea is the largest overall mountain in the world if you take into account not only its height or elevation above sea level, but also too if you went down to the ocean floor and were able to understand how big it is. It's an absolutely enormous structure, and that's again a result of those little hot spots, plumes of magma that are rising up, even though they aren't necessarily close to a tectonic plate boundary. Cinder volcanoes or cinder cone volcanoes are really unique too, really neat. They're an aggregation of pyroclastic material, much of what we mentioned earlier, and that sort of gets cemented together loosely. They're usually much steeper than our shield volcanoes, but also too because of the nature of how they're just a combination of ash, lapilli, and volcanic bombs, they're sort of cemented together loosely, and enough wind and erosion can cause these to erode very quickly. And finally, we have the composite volcano, which is kind of the classic volcano, if you will, something that comes to mind when we think of a typical volcano. Over on the right-hand side, you have a before and after picture of the Mount St. Helens eruption. So that picture up top was taken in 1978. Obviously, the one below was after the 1980 eruption, so a pretty incredible difference. With composite volcanoes, they're often very explosive when erupting. But then after that, they're followed by quiet, gentle flows of lava, and that's what makes them so typically such steep-sided mountains. These can make some of the most dramatic displays. We think of Mount Fuji in Japan. Mount St. Helens again is another great example. And also too, sometimes composite volcanoes are called stratovolcanoes as well. So with that being said, that's the completion of our Unit 9 notes on volcanoes. Thanks so much for watching.